Okay, so we're going to talk about how to switch back and forth from form to form. This is right now is in standard form. And before we do that, though, I wanted to point out one thing that I haven't talked about yet. That all the parabolas we've graphed so far have been looking like this, but a parabola can also go the other way. And the way you tell that is by looking at the leading coefficient. So like in this, notice in all of these, here's all the ones we've done in the past, there's a g of x equals 2x squared. Notice all of those, the leading coefficient is positive. There's a positive 2, a positive 1. If we go up here, if you multiply that out, you get a positive 1. You multiply that out, you get a positive 1. Notice right here, the leading coefficient will end up being 3 and 2 and 1. So all of these so far have been open up, meaning the arrows are pointing up in the end. So how do you get a parabola that looks like that? By putting a negative out front. So y equals negative 3x squared plus 4x minus 2. If you were to graph that thing, you would see that it would look like this. In fact, let's do it real quick since it's in standard form. Then you could say x is equal to negative b over 2a, and that would be negative 4 over 2 times negative 3 is negative 6, which would be 2/3. So the vertex is located at 2/3, and as the x-coordinate, and the y-coordinate would, of course, be f evaluated at 2/3. Let's change this to f of x. I keep forgetting to put it in function notation. Sorry about that, guys. So, and let's find out what f of 2/3 is real quick. So that would be negative 3 times 2/3 squared plus 4 times 2/3 minus 2. Of course, this is going to be, one of these 3's will cancel out, so that would be negative 4 over 3 plus 8 over 3 minus 2, and if I change 2 to thirds, that would be 6 over 3, wouldn't it? So negative 4/3 and negative 6/3 is negative 10/3, and negative 10/3 plus 8/3 is negative 2/3. So the vertex of this thing is 2/3 comma negative 2/3. So if we were to graph it, let's blow this up a little bit. So that'd be, what did I say it was? 2/3 negative 2/3. So over 2/3 down 2/3. So that'd be right about there somewhere. Stop that. So then if we check a 0, for example, if we plug in f of 0, that would give me negative 2, wouldn't it? So that would be right there. And if I plug in 1, that would give me a negative 3 plus 4 minus 2, which of course we already know what that is. What am I doing? That would be, oh yeah, no we don't. That would be negative 5 plus 4 is negative 1. So 1, I'm at negative 1. So you can see that this thing is open down, isn't it? So there'd be another dot right there, another dot right there, etc. Okay, so a negative leading coefficient tells you that it's open down instead of open up. Okay, now the main reason of this video is to talk about switching back and forth. So right now this is in standard form. Let's say I wanted to switch it to factored form. That, of course, is very easy because we know how to factor. So we just leave the y alone. Oh, let's change this to function notation. Sorry about that again, guys. We'll call it h of x. So if we want to write this in factored form, we're just going to factor it. So that would be x times x, and looks like 3 times 4 would give me 12, and 3x plus 4x would give me 7x. So that would be factored form. And of course, to go from factored form back to standard form, you just multiply it out. And of course we know what the answer is because we're looking at it, but we could go x times x, which is x squared, x times 4, which is positive 4x, 3 times x, which is 3x, and 3 times 4, which is 12. And therefore, we get right back where we started, x squared plus 7x plus 12. Okay? So that's switching from factored form, or from standard form to factored form, and then back to standard form. Okay? So then what if we wanted to switch it to vertex form? Okay? Well, that involves a method we've talked about before of completing the square. So now it's a little bit tricky here because I don't have a 0 on this side. So what I'm going to do is go h of x is equal to, and we're going to do x squared plus 7x, and I have to take half of 7 and square it. So that would be 7 halves squared, which would be plus 49 fourths plus 12. So I'm making this part a perfect square. Of course, notice I just added in 49 fourths, which means I have to subtract off 49 fourths. I don't want to add to the other side because that just gets messy over there, right? I want to keep everything on this side because I want in the end to have an equation with the dependent variable on the left side and everything else on the right side. So now that I've done this, I have a perfect square polynomial, so I can factor that into x plus 7 halves squared. And then what's left out here? Well, let's see. That would be plus 12. No, that would be plus 48 fourths minus 49 fourths. I change that so as a common denominator. And so I end up with h over x, or h of x is equal to x plus 7 halves squared minus 1/4. So this thing would be in vertex form now. And notice you can see the vertex. The vertex is 7 halves, no, negative 7 halves, comma, negative 1/4. Right? And just to make sure, let's go back up and check that. If I was to find the vertex from here, notice if I throw that into that formula, x equals negative b over 2a, then that would be negative 7 over 2 times 1 is 2. And look at that. It gets the right thing. Okay? So we just switched from standard form to vertex form by completing the square. Let me run through another one of those because I think that's going to be the harder thing, of course. Let's say g of x. Oops, sorry. G of x. G of x is equal to x squared plus 4x minus 4. So to get a perfect square, first thing I'm going to do is move the minus 4 out. And I'm going to take half of 4, which is 2. 2 squared is 4, so I'm going to put a plus 4 there, which means I need to put a minus 4 out there because I want to counterbalance those two things. So notice I still have the same equation up here because the 4 minus 4 gives me 0. Okay? Then I'm going to factor this into x plus 2 squared, and negative 4 minus 4 would be negative 8. And that is vertex form. Notice we can see the vertex. The vertex would be negative 2 comma negative 8, wouldn't it? Let me do one more example with a number out front. Okay, so again, I want to put this in vertex form. And remember, when we're completing a square, it's easier without a number out front. So what I'm going to do is I'm going to factor out a 2 from everything. x squared plus 8x minus 3. But, of course, I want that to be a perfect square, so I'm going to leave a little room there. And so I'm going to have a 2 here. Actually, no, I'm going to do that different. There's a couple ways to do this, and I think I'm going to do it this way. I'm going to move the negative 6 out to begin with. So I have a 2x squared plus 16x, put a little gap here, and then put a minus 6 out there. So then I'm going to factor out the 2. So that'd be 2 times x squared plus, plus 8x minus 6, okay? Now, I'm going to complete the square on the inside of the parentheses. So half of 8 is 4, 4 squared is 16. So I want a plus 16 in there. But notice when I put a 16 in there, I'm going to multiply that 16 by 2. So I'm actually adding 32 to the equation, which means I need to subtract a 32 out here. Because again, this 2 is multiplied by everything inside the parenthesis. So 2 times 16 is actually 32, so I have to subtract off a 32. So now I have, this is still k of x here, 2 times, and I'm going to factor that into x plus 4 squared. And of course out here I'm going to have a negative 38. And so, and there we have vertex form. And the vertex, you can tell really easily, would be negative 4 comma negative 38. And since the 2 is positive, just like we saw there, this would be open up. Okay, so that's switching back and forth between the different forms.